So let's start the class. I'm not going to wait that much. So electrical conductivity, as we know in the previous lecture, in the previous class, we talk about resistivity. So resistivity, or you can say this is your resistivity. What is this? R A by L. This is your what? Resistivity. So conductivity is just opposite of resistivity. Opposite means inverse. This is your resistivity. Okay. So if I need to find the conductivity, so that is your conductivity, that is resistivity. So what it going to be? L upon Ra. Okay. And if this have ohm into centimeter or meter, so this have what it have? Conductivity unit ohm into meter inverse, and that is known as Simon also. Okay. So electrical conductivity is a measure of how readily a material transmits an electric current. So that is the definition you know from the you can say smaller classes, but this is where you're going to face the problems or numerical stuff. Is this clear, everyone? Resistivity is resistance for a unit area, for a unit length. More than that, resistivity is a material property, and we know this is the formula for resistivity, and this is conductivity, just inverse of resistivity. The unit of resistivity is ohm meter, so ohm meter inverse, or this is also known as Simon, if I'm not wrong, in spelling wise at least. Simon go back wala Simon nahi. I mean Simon go back, that history Simon nahi, that Simon. Okay, or you can write this also. Is this clear, everyone? In physical conductivity of a material states that explains that how fast, how easily that particular material, that particular wire or anything going to conduct, going to transmit the electric charge. Whenever the transmission of electric charge is fast or fair enough, so in this way your current flow is going to be more, and the current flow is going to be more means that particular material is more conductor, means that particular material have property which is conductivity, as simple as that. So resistivity of a material, okay, that is something theory part, so let's discuss this. And then okay, we know there are three types of material: conductors, semiconductors, and insulator. Conductors are the materials that can pass electricity through them. Electrical conductivity is an intrinsic property. Okay, let me write instead of this. There are three types of material. So this is conductor, name itself, define. Then semiconductor. Semi means there are in between insulator or conductor. We're going to understand, or we're going to learn about in the 14th chapter of class 12. And then there is insulator. Okay, insulators. So everyone know the example of insulators. Can you give me 5 different example of insulators? And then conductors also. Any 5. Go ahead. Okay. So this is Siemens per meter and Greek letter this. I already explained this. Still for you guys, this is your conductivity. Give me beta in the chat box. Conductivity. Reverse of resistivity. Reverse of electrical resistivity, L upon R into A. Insulator, wood, plastic, glass, plastic, rubber, silk, cotton, conductor, any metal, human body, electrolytes. Sudarshan, glass is what beta? Conductor or insulator? Insulator. Okay. Anything, I mean 2 or 3 example of semiconductor also. So this is going to be this inverse, and that is Simon per meter. So Simon is what? 1 by omega. Yeah. So that also other than the silicon? There are two important ones, silicon, germanium, intrinsic, then RCM, galenide, and so and so. Is going to be the compound Simon per meter. So this is your data. Okay. So what is electrical conductivity? As we already defined in the previous page, it is an intrinsic property of a material which is defined the measure of amount of electrical current in a material can carry. Electrical conductivity is also known as specific conductance. Now what is specific conductance? As we know, resistivity also known as specific resistance. So just reverse of that, conductivity also known as specific conductance, nothing more than that. Clear? Resistance of a unit length or unit area is known as resistivity. In the same way, the conductivity of a unit length of a unit area of any particular material or wire or anything, that is known as conductance. Clear, everyone? And the SI unit is Siemens per meter. It is also defined as the ratio of the current density to the electrical field strength. It is represented by the Greek letters this, sigma. This is for question or germanium. Oh, yes, beta, germanium. Conductivity is okay. This relations for numerical part, and this is for your boards also, because in boards you need to write. Sometimes they ask questions like this also. Okay, is this clear, everyone? This is the whole sole important definition, you can say, of conductivity. Definition of conductivity. I already explained, but that is written on the words. As simple as that. Okay. So moving ahead. Now this is important. Why it is important? Because this is going to be your 2-3 mark short questions for boards. Okay, let me write here. This is going to be important for boards. And based on that, you get the graphical questions. Okay, semiconductor, I mean, which particular graph is going to follow the ohmic or Ohm's law? Which particular graph is ohmic conductor, which conductor, semiconductor, insulator? Clear? So one by one, each particular line or each particular paragraph you need to focus. So Ohm's law is not applicable for unilateral electrical element like diodes, transistors, as they allow current to flow through in one direction only. Clear, everyone? So these instrument basically known as semiconductor instrument or unilateral. Unilateral means in this particular instrument, diode or transistor, the electric field only and only going into one direction. So they are non-ohmic conductors or semiconductors. Or this particular word is written as non-ohmic materials. Non-ohmic materials. Non-ohmic materials, obviously they do not follow the Ohm's law. Okay, and I hope and I believe everyone know Ohm's law what it is. Clear? So there is a graph of Ohm's law, V directly proportional to I and V equals to IR. So they are not going to follow that particular linear line or directly proportional graph because they are non-ohmic materials. Clear, everyone? Okay, important for boards. Okay, let me write here. And for graphical question and for graphical questions. Clear, everyone? So that is non-ohmic materials. Specifically semiconductor, insulator, or these type of materials are known as non-ohmic. For non-linear, that is important word also. For non-linear electrical elements with parameters like capacitance, resistance, etc., the voltage and the current would not be constant with respect to time. making it difficult to use Ohm's law. Now what it is in general, like we have a circuit in the coming lectures, in the coming chapters specifically, we have this. This is your symbol of resistance, this is your symbol of capacitance. Okay, let me make it in a separate way. Capacitance. Okay, you know these things. This is the symbol of what? Inductance, a coil. So obviously this is going to follow the Ohm's law, but these two are not going to follow the Ohm's law. The voltage and the resistance, they are not directly proportional to in them. They are dependent on time. So when they are dependent on time, so they represent some you can say exponential graph or non-linear graph in general. Okay, let me write it down. This is your capacitance. This is your capacitance, and that is your inductance or inductor in general. Inductor. They follow non-linear graph. They follow non-linear, or instead of like this, they do not obey Ohm's law. Simple. So when they do not obey Ohm's law, so in general, the graph is, that is graph between V and I, graph between V and I. Let me write graph between, what I'm doing, graph between V and I is non-linear, as simple as that. Is it clear? Okay, so that is why this is written over here. Like in respect to time, there is a proper relation, like Q for capacitance, Q equals to Q naught e to the power some alpha t. Okay, so this is exponentially proportional. So obviously, if I'm going to derive with time, just so I becomes I naught e to the power minus alpha t. This is something relation. Alpha is time period, or you can say RC or something for capacitance. So this is not going to follow the Ohm's law, as simple as that. This relation might be something else. I'm not sure about this, but the scenario is in capacitance, in inductor. They do not follow Ohm's law. They do not obey Ohm's law, and the graph between V and I is non-linear. Clear, everyone? That is why it is important. So non-linear elements are those which do not have exact proportionality to applied voltage. What is this written over here? As we know, V equals to I. This is your Ohm's law. So any particular element or material in which this potential is directly not proportional, that particular element or you can say instrument, as example capacitance and inductor, is known as non-ohmic or non-linear graph, or they do not obey Ohm's law. Clear? Which means the resistance value of those elements change for different values of voltage and current. Example of non-linear elements are thyristor, electrical arc, etc. Capacitor, inductor also. And the circuit made up of them, like RC circuit, LR circuit, LC circuit, and so and so. They are separated, but they can be combined, either three of them or either two of them in a combination. Is this clear? Is this clear, everyone? So the combination or separately, they are not obey the Ohm's law. When they are not obey the Ohm's law, so the graph between V and I is non-linear. Why it is non-linear? Because in capacitance, this is the capacitance, the charge Q naught is the charge on a capacitor at initially when time is 0. So in this way, the charge on a capacitor, charge on the capacitor. So when the charge on the capacitor is this, so I is going to be this, and that is not going to this then. V directly proportional to not I. Okay, so that is written over here. They do not obey Ohm's law, and that is graph between V and I is nonlinear. More clearly, what is the statement about this? This is your V, this is your I. Just give me a minute. This is your V, this is your I, or you can do the vice versa. So this is not linear like this. This is not linear like this, but this is somewhere look like this. Okay, not this. This is wrong. This is correct. Clear, everyone? Whatever, what I'm saying, sorry, whatever in the above statements written, I just explain everything. I just make and draw everything. That is the meaning. You need to understand either in this way or in this way, in both the way also. Because if you need to write it down, so you need to write it down these sentences for picturization. What is going on here? What is the meaning of these sentences? This is the meaning. Meaning of this: do not follow or do not obey Ohm's law. This is the meaning. Okay. Harimesh, is it clear? Everyone? Okay. Good. Okay. So in the previous page, that is point number 2, I guess, right? Okay. Yes. So this is now your point number 3. The relation, even you can see whatever I drawn in the previous page, that is written over here. The relation between V and I does not, depends on the sign of V, positive or negative. That they are not in that particular sense. Like if we apply the positive, so that is going to directly proportional. If we apply the negative, that is not the case. In other words, if I is the current of a certain voltage, then reversing the direction of V, keeping its magnitude fixed, does not produce a current of the same magnitude as I in the opposite direction. This happens, for example, in the case of diode. What is the meaning of this? Diode is a semiconductor. Okay, this is the symbol of a diode. Yeah, this is your P part, this is your N part. Now, what it is written over in this diagram? This is your positive, this is your negative, right? So if in another case, this is your case number 1, this is your case number 1. This is then going to be the current. So in case number 2, if I'm reversing down, in case number 2, if I'm just reversing down the direction of what? Direction of your battery voltage terminal. This is now, it becomes negative, this is positive. Positive. In this case, beta, the current is not going to be same. Why so? Because diodes and transistors are unidirectional. Okay, so the direction of voltage is going to be matter here. More importantly, the I2 in second case and the I1 is first case are not equal. That is written. Clear, everyone? In the case of semiconductor, in the case of non-ohmic materials, that is going to be happen. Why it is going to be happen, we're going to understand in this diode case. Okay, Ohm's law is only applicable in metallic conductors, so it won't work in the case of non-metallic conductors. Clear, everyone? There is one more line maybe missing. Let me check. Okay, there is no written down. One line missing. Assumption. Ohm's law is only applicable in metallic conductors for constant temperature only. Why should I write this for constant temperature only? Because you're going to see with the change in temperature, we are going to see the change in resistance, as well as we are going to see the change in resistivity. So when resistance is going to change with time, right, with the temperature, like you change the temperature of a room or your surrounding, so the resistance is going to be changed. So in that particular case also, V equals to IR, that is your Ohm's law, is not going to fulfill. Okay, this is only fulfill in this assumption. Which assumption? Above assumption. In this assumption. What happened to my writing suddenly? In this assumption. Is this clear? Everyone? Okay. This everything seems very basic, but when they ask question in assertion reason form or in theoretical form or in boards specifically, you don't get the specific words to write. So understand as well as and try to form the words by yourself, because specific thing I tell you since beginning, in physics or in PCM, I don't know about chemistry much, but I know about physics and maths as well as. You cannot learn anything. Anything means anything. If you try to learn, if you go for the learn something, believe me, beta, neither you going to score good, neither you going to understand anything. And being the JE aspirant, if you are you can say preparing for NEET or you have physics, chemistry, bio instead of maths. So I say specific few things to learn, because then you understand or then you get good marks in boards as well as then you get good marks in NEET as well as. But here that is not going to help you out. Believe me. If you do that, so then there is your loss. Okay. I suggest, I told you, never ever do that. Clear? Clear everyone? Just type or say, or if it is clear, so yeah. So this is what is electrical resistivity. We already talked about it. Let's revise this thing. Electrical resistivity is the reciprocal of electrical conductivity. It is the measure of ability of a material to oppose the flow of current. Okay, metals are good conductors of electricity, hence they have low resistivity. The insulator like rubber, glass, graphite, plastic, etc. have very high resistivity when compared to the metallic conductor, aluminium, copper, iron. The third type is the semiconductor, which comes in between the conductors and insulators. Their resistivity decreases with the increase in temperature. This is very important, man. Okay, mark it out. On this particular single line, you can get the question, either in your JEE, either in your boards. Okay, what is written over here? Their resistivity decrease with increase in temperature. What is the meaning of that? Resistivity have inverse relation with temperature for what? For semiconductors. Clear? So as a note, how you can write it down? Note. I am going to give you the graph whenever it is necessary or required. Don't worry. In note, you can write it down for semiconductors. For semiconductors. Resistivity is what is written over there. Resistivity decreases with increase in temperature. Resistivity is negatively. So resistivity is independent of temperature. No, who said that? Resistivity is it is not. If you asking or you telling, I mean you are tell me this line or you ask. Oh no, it is not. For semiconductors resistivity, for semiconductor resistivity is negative. What I'm writing for semiconductor resistivity is negatively not negative, inversely. Resistivity is inversely proportional to temperature. Yeah. Inversely proportional to temperature. What is the meaning of saying that? Okay, in the previous class I told you the arrow meaning. So this is suppose your resistivity of semiconductor. So it is going to increase if, or you can say when, temperature is going to decrease, or vice versa. It is going to decrease if temperature is going to increase. The above arrow, what I am saying today, me a minute. Okay, let me explain to you, the new student. This above arrow means increase, or this downward arrow means decrease. Okay, is this clear, beta? Everyone? See, Kritika, in the previous lecture, I give you some relation for resistance, and this R equals to R naught alpha T. So if resistance is directly proportional to temperature, so resistivity is also going to increase with temperature. Okay. So this is the third type is semiconductor, which comes in between the conductor and insulator, and their resistivity is inversely proportional to. Clear? So this is your resistivity of some materials. Conductors, like you can see the range. Focus on the range. This is your range for conductors. Like silver have least resistivity. What is the meaning of saying that? Its conductivity is very high, and that is why it is lie in the range of conductor. Like you can see the conductivity of silver is 1 by resistivity of silver, which is, if I am just forget 1 by 6, so 10 to the power 8 divided by 1.60, and that is Simon per meter. So now you can see how fast the charged particle can flow within a minute or within a second. That much fast they flow, and that is why the moment you turn on or just tap the switch, you can turn on your electric bulb, and then you can your fan is going to start, your TV is going to start within a second, within a, not even a minute, within a microsecond, not within a second, even micro or milliseconds. Okay. In the same way, you can understand for copper. In the same way, aluminium, tungsten, nickel, iron, chromium, mercury, manganese. These are the orders of resistivity. From the orders of resistivity, you can tell, or you can not guess, but exactly you can tell the order of conductivity just by reversing this. Clear? So if conductivity is given, you can tell the order or about the resistivity, and if resistivity is given, so you can tell about the order or the actual value of conductivity. Everyone clear? Okay. Is this clear, everyone? Okay. In the same way, alloys. Alloy, you can say, what is alloy? Tell me, anyone. What is alloy? What do you understand from alloy? Homogeneous mixture of metals. Mixture of metals. Yes. Mixture of metals and non-metals. There is non-metal in this. Copper, nickel. I don't think so. Okay. Nickel, chromium, manganese. One thing you missing everywhere, every particular student, Kritika, Josna, Harimahesh. Homogeneous or heterogeneous, I don't know about that much, but fixed ratio. They are mixed in a particular fixed ratio. If like copper is going to be 90%, so nickel is going to be 10%. Always and always for constant. Okay. So alloy is a mixture of two or more than two conductor, but in a fixed ratio. Fixed ratio. Okay. Now you understood from this. And write it down. I'm not going to write everything. So this is resistivity of some materials which lie as a conductor also, but they are not pure conductor. They are mixed, or you can say heterogeneous or maybe homogeneous mixture of these particular conductors, but in fixed ratio. So constantan is a alloy of copper and nickel. Manganese is a alloy of copper, manganese, and nickel. Nichrome is a alloy of nickel, chromium, manganese, and iron. And their resistivity is 49 into 10 to the power 6, 44 into 10 to the power 6. This is very easy. So you can find this conductivity is this 10 to the power 6 and 100. So which is 10 to the power 4 Simon per meter. Okay. because that is divided by 100. So that is easy one. Clear everyone? So still it is very high. You can see that is least, but it is very high. Even being the least, even being the minimum also. Then moving ahead, resistivity of some materials. Now you can see these are insulator, pure insulator, non-conductor. You can write it down. Or non-anomic material, you can also write it down. Okay, let me write it down. Conductor. Non-conductor is something word or not? Non-ohmic, you can write it down. That is the perfect. Okay, so glass, hard rubber, ebonite, diamond, paper dry. 10 to the power 10 to the 10 to the power 12. So if you just take 10 to the power 10 even, or you can say 11, resistivity it is ohm meter, right? So then you can just do the conductivity, which is 1 by 10 to the power 11, which is 10 to the power minus 11 Simon per Simon per meter. That is why they are lie under the category of insulator. Second thing, that is why they do not conduct electricity. Clear? Because the conductivity is very, very less. More than that, you can reverse the order also. You can tell in a format of resistivity. The resistivity is very, very high. Clear everyone? You can see the range 10 to the power 10 to 14, 13, 16, 15, 17, 12, 13 and 10 to the power 12. Okay. So that is just a data, but it is necessary to understand. This is important thing. Color coding. Color coding of resistance. If you understand this, so then your life is easy for so many number of years. Since right now, okay, you're going to when you're going to, let me see, they given this thing, BB Roy have Great Britain, very good life. No, they don't. I need to tell you this rhyme or this something. Maybe you know before. So how you can remember this? First of all, what it is, there is a method in the laboratory, in industry. You cannot, no one is going to tell this particular resistance is going to be that much ohm. You need to find yourself and buy the color code, and you're going to see color code in proper way also in this class. By the color code, you just automatically calculated the resistance of that. So first of all, black color is zero number and multiplier and tolerance. Tolerance is the, you can say, impurity or non-impurity in, or you can say error. Okay. So just quickly I give you a glance first and then I'll reverse back. Just okay. So in industry, you can see right now everyone here. Focus here. In the industry means in the labs or whenever you get your resistor in your hand, a small tiny piece instrument you get in this way. So first digit color gives you the first significant figure. Okay. The second digit is going to give you the 10th number. For example, your resistance is going to be 20 kilo ohm. Or you can say 23 kilo ohm. So how you can find? First color is give you the first significant figure. Second color is give you the second digit. This is first digit. Let me put something else. This is first digit. This is second digit. This is multiplier. And then, okay, I'll forget one thing. Then this is tolerance, plus minus error, or you can say tolerance. And in this way, you can get your resistance. This is clear, everyone? Like gold, silver, and none. If there is none, black color you can see like this. So the tolerance is going to be, the error is going to be plus minus 20, either plus 20, either minus. You don't need to worry about it. If it is gold and silver, sorry. So in the gold and silver, 5% only. Clear, everyone? Clear? Is this so? In this way, you're going to find. Now, coming back to the topic, just taking 2 steps back. So, how you can remember? B.B. Roy have Great Britain wife wearing blue, violet, something this. Okay, let me remember this rhyme also myself. There's a simple rhyme. And if you know, if you B.B. Roy table, color code. So this is B.B. Roy of Great Britain has a very good wife and images. Wait. Wearing gold, silver, jewelry. Something look like this. I mean something they rhyme in this way. Yeah. B.B. Roy of Great Britain has a very good wife. Wife stands for wife. Wearing gold, silver jewelry. Yeah, that is the proper word. B.B. Roy of Great Britain. Okay. Sir, can you show the before slide? Which slide better? This one or this one? Which particular slide you are talking about? Jyotsna, this one or the next one? Got it. Okay. So, how you can rhyme it out? B.B. Roy have okay. I am also confused. B.B. Roy. B.B. Roy of Great Britain has a very good wife. Let me write it out. B.B. Roy of Great Britain. What is the spelling of Britain? B-R-I-T-N. Britain has a very good wife wearing gold, okay, silver necklace. Yeah, that is the perfect. Okay, now you understand in this way. See how you can rearrange this terminology. You just either you learn it out or either you remember this or either you can make your own self something. But this is properly, you can say we use from years. So B.B. Roy of Great Britain has a very good wife wearing gold silver necklace. What is the meaning of that? See, B.B. Roy stands for first this. First B stands for black. Second B stands for brown. So starting from 0, 0, then 1, then 2, then 3, then 4. Then R stands for R obviously, and then the 0, 1, 2. Then O it stands for, I mean Roy. O stands for orange, Y stands for yellow. Then off you can skip it out, green or Great Britain. G stands for green, so that is G, or you can say fifth number G. Britain blue, okay, stands for sixth number. Has nothing. V stands for violet. In the next slide, I need to write it down. Okay, let me write it down here as well, and then we will skip violet. And then G stands for this. G stands for beta. Okay, nothing but W. Wife stands for this white, and then wearing is nothing. Then gold for tolerance. Then silver for tolerance, and net for none. Okay, so this in this way, yeah, violet, gray, white, gold, silver, no color or none. So that in this way you can write it down or you can remember. Okay, let me write it down in the B.B. Roy of Great Britain. That I forgot also. Great Britain has a very wife, wearing gold, silver necklace. Wearing gold, silver necklace. Necklace. Maybe the spelling of this is going to be wrong. But again, this is, it stands for 0, then 1, then 2, then 3, then 4. Skip that. 5th, it stands for green, then 6th for blue. You need to skip S, A, then this. For 7 for violet, and then for G for gray, 8, then for 9 for W, and then wearing, you need to skip, and then gold for gold, which is tolerance 10 to the power minus 10, or you can say 5% tolerance. Okay, then silver 10% tolerance, then that is 20% tolerance. Is this clear? I will take the charge and come, sir. I don't know about, I mean, I didn't get this. I will, Sudarshan. Okay, I will take the charger. I thought what particular charge you need to take from here. I thought you were going to start teaching us. Like, sir, I teach you in a better something rhyme. I think in this way. Okay. So in this way, you need to remember this, or you need to understand this. Clear? Just this single sentence going to help you out a lot. Because then you don't need to learn for which particular color, for which particular number it is going to be. And for multiplier, obviously multiplier is going to be the multiple of 10 to the power 1. As you can see in this, 10 multiplier 1, then 10 to the power 1, then 10 to the power 2, 3, 4, 5, 6. Okay, moving ahead, 7, 8, 9, 10 to the power minus 1, 10 to the power minus 2 means 5%, 10%, and 20%. Because these are the tolerance, or you can say, good evening, sir. Right now I joined late. Okay, I joined late because there was no power in it. It's okay, beta. Okay, is this clear, everyone? Just BB Roy of Great Britain wife has a very good wife wearing gold silver necklace. Simple. The simple line going to help you all out. I mean, help you guys a lot. Clear, everyone? So this is your resistivity formula. In the previous class, we also derived that. For those who are new to this, materials having electric field and current density will have the following resistivity formula. This is your microscopic forms of Ohm's law also. What it is? J, which is current density, equals to sigma upon E, which is sigma, you can say 1 by E upon rho. So this is just the reverse of everything. You can note it down, and this is your microscopic form of Ohm's law, or vector form of Ohm's law. In the great detail, we discussed this thing in the previous class. Vector form of Ohm's law, or microscopic form of Ohm's law. J equals to sigma E. Microscopic form of Ohm's, and that is important too in each perspective, for board wise, for JE wise, because they ask the derivation of this directly. Okay, this relation we also cover up. So these are just the formula directly. Conductors, what it is? Yeah, conductors with a uniform cross section. Conductors with a uniform cross section and uniform flow of electric current will have the following resistivity formula, that arises from resistance is directly proportional to length, and resistance is inversely proportional to area. Combining both equations, we get resistance is, you can say, rho This is resistivity rho L by A. So reversing this thing, this resistivity comes R A upon L. Okay, just rearranging the formula of what we already do cover in the previous. Dimension of resistivity, that is going to be the R's directly, so you can note it down. Meter, length inverse, temperature to the power minus 3, area to the power minus 2. Okay. CGS unit, important one. Ohm centimeter. SI unit, important one. Ohm meter. Clear everything? We already go through this particular, so I am not focusing, that's why that much. Clear, beta? Okay. So this is your factors determining the resistivity of material. Following are the factors that determine the resistivity of materials: nature of materials and temperature. And moving ahead, this is again resistor color coding. So we done this part. There is no, this is highlight of the resistor color coding, how we can find it down. And this is temperature dependence of resistivity. And this is temperature dependence of resistivity. This is question, and then oh, nice. Okay, just take a break because theory wise we finished almost 70-80%. Then we're going to discuss a little bit more. Okay. Okay. There's a break, and after there is a break, or after a break we discuss something more. Hello, hello. Am I audible? Am I audible? Am I visible? Beta, let me do one little bit. Okay, so just start. Yeah. So till now everything is clear to each and every particular student. Good. So, what is written over here? Following are the factors that determine the resistivity of a material. As you can see, the resistivity is this, which is rho R A by L. But in general, what is this? I mean, what is resistivity in general? In general means we say resistivity is specific resistance, because that is really important in you to understand. That is specific resistance. Specific resistance. And what is specific resistance? Tell me. I told you in the previous class what is specific resistance. Anyone? Tell me, beta, what is specific? Seriously, seriously, Kritika. This answer I never ever expect, at least. Specific resistance is what? Resistivity. Wow. I mean, am I joking to you, right? this is this is fun, but sorry, I'm asking the other thing what I need to write it down here, not reverse. Obviously, specific resistance is resistivity, but in the previous class I told you what is the meaning and what specific resistance is other than resistivity. Now I reframe my question. Tell me, anyone. In the previous class, maybe you remember, maybe you don't. I don't take your time. Resistance, resistance of a unit length or area. Okay. So when I'm saying this, okay. Yeah. So suppose this is your something, a material, any particular thing. The length of this particular specimen is 1 meter, and the area is also 1 meter square. Whatever the resistance, this particular thing, per unit length and per unit cross section. Yes, yes, beta Sudarshan. Okay, so that is resistance. The resistance of a unit length or unit area is known as specific resistance. So there is a question going to be where we are going to use this language, this particular definition, and that is why resistivity is nature of materials, more importantly, and temperature dependent. It is dependent on temperature, or it is dependent on what? Nature of material. For example, aluminium has something other resistivity, or your copper has something other. Even in conductors, not talking about conductor, insulator, semiconductor. Okay, so this is even in conductors. Aluminium has something else, iron has something else, chromium, nickel have something else. Resistivity I'm talking about. Clear? So that is material dependent, nature of, not area or length. Clear for everyone? Okay, good. This we already done, but again, black, brown, red, orange, yellow. BB Roy has Great Britain wife wearing what? Gold, silver necklace. Okay, so black stands for 0, brown for 1, red for 2, orange for 3, yellow for 4, green for this. Now this is going to be black for 0, brown for 1. I mean, you need to start your digits from 0 and the multiply 10 to the power 0, which is 1. 10 to the power, which multiply, it is multiplier, so 10 to the power. Okay, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, and in this way you can go ahead. Tolerance for brown is 1, red is 2, 0.5, but mainly in general you need to just write it down, these tolerance, this one, and you don't need to worry this much also. So just this kind of question you're going to face in JEE Mains. Okay, if you are going to lucky enough. So again, BB Roy has a Great Britain wife wearing gold silver necklace is going to help you out. You just start with the 0. How you can find? This first digit is written over there, first significant figure, second digit is in this way. Then third color is going to give you the multiplier of time. Suppose here yellow. So yellow have 4. Okay. Okay, tell me this particular, from this particular left hand box or table, and from the right hand color code, just tell me what the resistance of this. Go ahead. What is resistance of above? What is the resistance of above resistor? Resistance of above resistor. Okay. Tell me. Write it down here. And after multiplier, either you can write in the plus minus percentage or either in 0 point something. Again, I am telling you guys, first digit, first significant figure, second digit, second, third into the 10th to the power multiplier, and then tolerance is simple. Gold, silver, none. So tell me the resistance of this. Okay. And I just remove this and write something else. 54. Now it's because then I automatically type. Did you all understand this now? What is going to be? You need to use the table in the left hand end, and according to the table, according to the color code, you need to find the resistance of a resistor. This is resistor color coding, and you need to tell me how much resistance this particular resistor have, the above resistor. Tell me. Tell me, but this is very easy, and the questions like this you need to face. Okay, so do it quickly. Seriously, that much time taken it is. First color is red, second is orange, third is yellow, and then none. If you are confusing in colors, so I'll tell you red, orange, yellow, and then none. Me beta, this is very easy, and I hope and I believe everyone know this. I mean, everyone can find this. Rameshwar, Nikhila, Trivikram, Muktukumaran, Kaila, Netra, Shutika, Yajira. Did you understand, beta Yajira? Hmm? I'm audible. Shreya, did you understand? Yajira, beta. Yes, sir. Okay, tell me the answer then. See, if you take that much time for this question, so how are you going to be solve the problem? Tell me, anyone or everyone? That is very easy. Same question I ask. Believe me. Just after the glance, you can tell me. Or should I write it down, this one also? Tell me, beta, anyone or everyone. Seriously, this is that much hard. I literally wanted to know. Write it down somewhere, anything. Yes, sir. Yes, sir. 2 minutes. You people take 2 minutes for this. That is not even 20 seconds question. And if I'm saying so, believe me, 20 seconds. I'm just going to wait a minute only. Vishwanath. And please, everyone, turn on your camera. Okay? So I can able to see you guys. Okay, tell me generally what difficulty you find in this. What difficulty you face here. I wanted to know. If you understand this particular thing, that is very easy. And if you don't understand, then why don't you tell me? Tell me. What is difficult in this? What are you writing so much? Tell me, beta, anyone or everyone? I'm asking this question in general. You tell me, Sudarshan. Why are you not able to give me the answer? Tell me, beta. Sudarshan, speak up. What you take time? That one. Hmm. Tell me, am I audible? Hello? This is a genuine question to each and every one. If you are not want to talk, so at least let me down. Write it down here. Could not able to understand. So why don't you ask? That's the question. If you are not able to understand, sir, how to find tolerance? See, that tolerance is nothing. Neither gold, neither silver. So 20%. Is it 2, 3, 2 to the power? Yes, it is. See, the new student tell me the answer and you don't. So something you need to understand. If you are not understanding a bit means even a 10%, even 1%, 2%. You need to ask and at that moment. What hard in this? You just need to write it down the digit and then follow the rule. Since beginning, uh, this is the main learn concept here. So if this is going to be resistance, okay, I don't want to say this word, but see, if you are preparing for J, so shame on you guys. Believe me on this. Resistance R. First color is red. Red is 2. Simple. 2. Second color is orange. Second color, third. Fourth, yellow. 10 to the power 4. Tolerance, nothing color. None color. Plus minus 20%. What hard in this? Tell me. This is written over here. I explain you this. I explain you how to remember even. See, suppose this table is not given. Then you are not able to write it down this in 10 minutes or 15 minutes, right? See, one thing I want to tell you. If you are serious enough, let me be clear with you guys. If you are serious enough for JE, okay, JE preparation, I'm saying. So try to develop that particular, you can say, hunger in yours to solve question after seeing within 30 seconds. 30 seconds. I'm saying. Okay. If you are able to solve this kind of question in 30 seconds, then you take at least 1.5 minutes or 2 minutes to solve something moderate or complex question. Believe me. If you are not able to understand this or tell me this or solve this, then how can you go for, you can say, complex problems? Tell me. And this, Sudarshan beta, if you are not could not able to understand, then why don't you ask me? Even before the this particular break time. Okay, tell me. In the break time, in the before this break time, we did this, and before this, that's why before this I show you this and write you here like first significant figure, second into multiplier, then plus minus. This is tolerance. Dot 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 or dash, and then there is a ohm, or you can say unit of resistance. Tell me, beta. See, that's why I'm saying ask. If you are not asking more than that, you are just turning off everyone here, turn off their cameras. I just can able to see this Hari Mahesh and that's now this Saga Murugan. So how can I understand without seeing you guys what you going through? Even if you am seeing, so someone is not understanding, someone is yawning, so I can understand. Like I need to change the method, or that particular student is not able to understand. So tell me. See, you make me to be that hard or rude again and again. Okay. See, the more you enjoy, the more you try to learn, the more you get. As simple as that. In physics, at least. The more you make this particular lecture, this more, not this particular lecture, but this particular subject, topic, subtopic, any particular thing, boring, the more it becomes boring. Okay. And believe me, this is going to help you out in your college life, in your labs, in your experiment. Nothing, any particular theory. Why so I'm saying this? Because you get this tiny piece of resistor in your head, and then if you are not understanding here, and you get clear in any particular good college, or you get admission, so then you're going to Google it out. Then you're going to read out for a 15 minutes, 20 minutes, and then you're able to tell. And in this meanwhile time frame, everyone going to judge you. Everyone means everyone, believe me. The lab assistant, the class fellow of yours, and obviously the teacher who going to take your viva. Like the particular student is not, he, she I'm talking about in general. If that particular student is not able to tell me the value of this small resistor or resistance, so how he or she going to perform the experiments, going to take the readings, going to do the calculation? Because in labs, believe me, you need to be so patient. Like sometimes you take 5, 6, 10 readings, and after calculation, the data is not sufficient, or you are not reaching the 50% of that particular experiment. Then you need to do again. This is how scientific world runs on. This is how the experiment thing going on. Sometimes the human error, sometimes you can say your instrument error, sometimes your environmental error is going to be. After clearing out everything, then going to be work it out. But you are not focusing enough here only. So this is request, suggestion, advice. If you are not understanding 5%, or you can say 2%, 1%, stop me in between, ask me at that particular slide, at that particular page. Because the moment I jump, the moment I switch the page, or you can say move forward in the page, I expect everyone is getting. And that is why I just say type you understand, yes sir, or no sir, or whatever you want to do. Okay. Is this clear, Sudarshan? because I don't want to see this sentence again from any particular. See, this is very, very basic, because if it is not going to help you out, so the next subtopics or topics, how are you going to cope up? Okay, so much gyan in one slide. Okay, so simple thing, you need to just remember this BB Roy of Great Britain, because this table is not going to help you. I mean, this table is not with you everywhere, na? So just BB Roy of Great Britain, right? Whenever you see this resistor or this question kind of thing, I mean this question, just remember this, just write it down in pen, paper, in note, and start with the zero. The main thing, note this line also somewhere. You need to start with zero. Need to start with zero. And obviously, if you going to start with zero, so you never ever seen black here. Simple as that. Okay. If in any particular case black is going to be here, so that is not possible or impractical. That is very basic thing. If I put black here, so 0 and then 2 and then 3, so that can be, I mean, not impractical, but that is going to be in the range of 1, because 0, then you can say, suppose here it is black, just paint it out. So first significant figure is going to be 0. It is not going to help out. Clear na? Because second can be 0, first cannot be 0. Reverse can be true, but 0 is not going to, because 0 into then 2 or 3, whatever it is going to be 0, not 30. Most of the time here either red, either brown, or either this orange, you're going to find that out. So this is highlights of this particular resistor color coding as follows. The resistor has 4 color bands. The first band is red from the previous, and they tell you this about, okay, not the previous one, but for this particular, how you need to find it, how you need to write it down. The first band is red. From the table we know the red stands from the significant digit 2. The second band is red 2, so this indicative, the second significant digit is also 2. The third one is multiplier of 10 to the power. So here it is black, so it is 0. It is 2, it is 2, it is gold. Okay, because it is written over, tolerance is gold, so that is 5%. So third one is 0, so 10 to the power 0, 1. So the fourth band is gold, which indicates a tolerance of plus minus 5%. Hence the resistor has a resistance of 22 into 1 ohm plus minus this much tolerance. So the resistance of this beta is nothing but R2, because of first significant, I mean because of first color, then 2 because of this, then 10 to the power 0 plus minus 5%. Okay, and this is going to be very easy. Resistance R is 10 to the power 0, or anything to the power 0 is 1. 22 plus minus 5% ohm. Or you can write it down, 22 ohm plus minus 5% tolerance, or you can say error. Clear everyone? Okay. Is this clear now everyone? Whatever I said it to you, whatever I explained in the previous slide, that is written over here. Nothing. And this written thing is not going to help you out until unless you understand. Because within a minute, the moment I change the slide, everyone, believe me, everyone is not going to write it down the same sentences. Even I am not going to. Okay, so understanding is the main thing. You don't need to learn this by heart. You cannot learn everything by heart. Now this is important, temperature dependence of resistivity for okay, this is exact, but the color is so faded. So this is your resistivity, and this is your temperature. Okay. So the temperature dependence of resistivity, where it came from, as we know the resistance also, R equals to R naught 1 plus alpha T minus T naught. What is T naught? Initial temperature. Or what is R naught beta? Resistance at initial temperature. Okay. T naught initial temperature or temperature at starting time 0 second. Initial temperature. R naught initial, and then it is going to be okay. RT initial resistance. Okay. In a same way, when your resistance is going to be, so in the same pattern, the resistivity is going to be rho of T is nothing but resistance, sorry, resistivity at particular temperature. Okay, let me write it down. Resistivity, I'll make you, I mean, just give me a minute. I'll tell you from where and how we get this. Resistivity at heat temperature. Okay, then this is resistivity at zero temperature, or you can say initial temperature, but 0 Kelvin in general we say that. And then T naught is temperature at initial or 0 Kelvin, and T is temperature, as simple as that. Okay, so this is your relation, and in this way for ohmic resistance. What color I do for ohmic materials or conductors, you can say, but that is the perfect word. Is this clear? Where from it comes? Like in the previous lecture, I'll tell you, the resistivity of a material is inversely proportional to the relaxation time, where relaxation time is nothing but Vrms by lambda, where lambda is mean free path, Vrms is the root mean square velocity of moving electron or charged particle. Okay, so or this Vrms is increased with temperature as mean free path decrease, or you can say, yeah. So Vrms in general, or kinetic energy, is related to temperature. From everything, from this particular 2-3 combination, we get linearly dependent of resistivity, which is rho of T, rho alpha plus T. What is the sense of saying that? What is the meaning of saying that? This particular line is not correct. Just give me a minute. This is correct. Just wait for that. This is, here it is. Not starting from the 0, but something from any particular slope. Okay. So beta, in the previous class, we derived this in a great explanatory manner. Your resistivity is inversely proportional to tau. This tau is relaxation time. Okay, this is your first equation you can write. And then tau is, if I'm not wrong, if it is time, so distance upon velocity, then it is going to be, or velocity upon distance, Vrms upon lambda, where this lambda is mean free path. Now what it is? Mean free path between the two successive collisions. In the same way, tau is what? Time duration between two successive collision of ions or charged particle, or ions or electrons in general. So, okay, this lambda or Vrms is dependent on temperature. So combining both these things, rho inversely 1 by tau, that is going to be, tau is what? Then it is going to be in this way, if I'm not wrong. So from here we get this relation of temperature dependence. Means why so? Because root mean square speed increase with temperature and mean free path is going to be decreased. So resistivity and the resistance of a material also rises with temperature. Sorry, this RMS. So the mostly linear and it is given to be. So from here, rho of T, this is not 1 plus alpha T, or this T can be T minus T naught. This T is temperature here, but the temperature difference. Okay, so this is the basic root. In the previous class, in which kinetic theory of gases, VRMS is increases with temperature. That is very famous relation where kinetic energy is 3 by 2 kT. K is Boltzmann constant, T is temperature. Okay, I'm not going in that much detail, but that is the root cause. Clear, everyone? Sir, can you explain that graph? Yeah, why not? See, for okay, what is the meaning of this particular graph? This is not at even 0 degree, it is going to give you some value, which is 1 plus alpha T naught. This particular value at 0 degree temperature. Resistivity at 0 degree, or you can say Kelvin. Why so? Because this root of T, or you can say resistivity of temperature, root rho naught 1 plus alpha or minus, I mean, if I do the mod thing. So the meaning of this particular graph is my resistivity is proportional to the temperature with alpha, which is alpha is some constant, and helping out with this, this is going to be linear, but not starting from the origin. Simple meaning. This has some constant C. Like we have this equation now, y equals to mx plus c. Okay, so m is slope, c is sub constant. You can say intercept, if I'm not wrong in the proper mathematical term. So that is your intercept. That is meaning of, I mean, that is how we can understand about this relation. Is this clear, everyone? And from where it arises? It arises from here. In the previous class, we did this in great detail. Okay. If it is given. Is this clear, everyone? Okay, should I move ahead? Everyone means everyone. Good. So this is temperature dependence of resistivity. Resistivity varies differently with different materials. For example, materials like manganese, obviously, and nichrome are less likely to change their resistivity temperature. In case of semiconductors, their resistivity decreases with temperature. That's what I want to draw even. They tell, so that is very good. This is your graph for resistor. That is your graph for semiconductor. Just give me a minute. So this is for, suppose this is your resistivity, this is your temperature. This is your resistivity, this is your temperature. So tell me how it is going to be. The second, tell me, because verbally I'll tell you, and I make it noted down, you guys also. So that is for conductors, or you can say, yeah, conductors or ohmic materials, and that is for semiconductors. So which particular type of graph you expect for semiconductors? Tell me, beta. Semi go down. Semi go down. Is the meaning of this. Semi go down. Okay. How I can understand this particular word of your what is you written? Semi go down. What is the meaning? Can anyone explain? Semiconductor graph goes down. Yes, beta, it is. But how? Directly, linearly, non-linearly, inversely, in which way? Is this, okay, this is your semiconductor, this is your conductor. So is this going to be in this way? Semiconductor decreases, temperature increases. Yeah, I know this thing, but in this way, beta. I mean, this way or SC stands for semiconductor. 1 by tau square. I mean, this. Why should I write tau? In this way or so in which way? Way. The sentences you write in a correct manner, in a correct formula, but in which way? Okay, in PN junction in semiconductor there is a relation. What is? I am going to write it down. N equals to N naught e to the power minus Eg upon 2 kT. Even this relation is not, sir, I think it will go down because resistivity will keep going down as resistivity. Okay, goes okay. Main array beta, I want to ask exponential decrease, linear decrease, or square decrease, or whatsoever. Not this. This I know also. Okay, this is going to be exponentially decrease. What is the meaning of this? Exponentially decrease, something in this way. This sentence. What is this? This is the concentration of your electronic charge in PN junction where temperature is more than the 0 Kelvin. So more your recombination is going to be, what is the, I mean, what is happening with increase in temperature? The more number of free electrons going to be generated with the temperature, more conductivity is going to be increases. So more conductivity increases means less resistivity, and that is not up to the mark even. Something look like, okay, wait, I need to do in a one go. Mhm. Something look like this. Now that is perfect. It is exponentially decreases. The correct word. If someone asks what how it is going to be decreases, so your answer, your response is exponentially decreases. Exponentially decreases. From where it comes? From this relation it comes. Sir, so that graph is called exponentially decreasing trend. Yes. Okay, not inversely. This is your inversely. This is your 1 by t square, or you can say square of inverse or inversely square. Okay, that is wrong. Both. In this way it is going to decrease. So they ask deliberately graph, I mean they give graph like this and above other graph also, and the question somewhere is look like this, pick the non-ohmic conductors from the given graphical. Non-ohmic means obviously the materials which are going to be not follow, not obey the Ohm's law, or they have this semiconductors or diode or transistor and so on. So clear? So from three different graphs, one of the graph is look like this, and you need to choose this graph. Clear, everyone? Is this clear with everyone? Good. You too, beta, Nichila, the new one. Is this clear? Good. Okay. So now this is your first question, and I am not going to tell. Believe me. Solve it out and let me know. Everything is written over here. Violet, green, red, gold. Tell me the answer. Correct one. Just tell me the plus before plus minus, because this after plus minus is from the proper table. You need to understand the proper table from this this this. Yeah, 1 second. Where is this proper table? This one. As you can see, na tolerance 1, 2, 0.5. This one. So from that, so just tell me this. Which one is going to be? I mean, without tolerance, you can tell me one. And that is easy. Just write it down, that particular line, that particular sentence. B.B. Roy of Great Britain has a very good wife wearing gold silver necklace. Okay. And automatically you tell me the answer. Go ahead. Because after these questions, I mean after that, D. Okay. Beta, you tell me or you ask me. D. Violet. Okay, let me write it down because I don't written by heart. B. B. Roy has great of Great Britain has a very So if I'm starting with 0, okay, yeah, then it is everything is covered. So starting 0, 1, 2, 3, 4, 5, 6, 7. So 7 correct. Okay. So 5 is not going to be. So it can be this one or this one. Then green. This one. Then red. So it can be this or this. So how we can find this? Let's see that. Okay. 75 into 10 to the power 2. Yes, beta. I got it. So plus 5% of tolerance of 7500. That's what is that is me. That is the major thing you need to tell. 5% tolerance of what? 5% tolerance of the this. Okay, how you can write it down plus minus thing in this way? This is the way. 5% of what? 5% of whatever the resistance you can get. So either it is D, either it is B. It is dependent on the these three things first, and then in the percentage wise you find the percentage and then plus minus. Is this clear? So the resistance could be 7.5 kilogram plus minus 375, either plus either minus, not 750. Okay, is this clear everyone? How it is D? Okay, so this is the way. Simple. Just remember this line. Mark it out the till multiplier, and whatever the color it is given, find the percentage. I mean, you know the percentage. For gold it is 5, for silver it is 10. If instead of this it is going to be silver, so that is directly 10%, 750. So instead of this you can write, for silver I am talking about 7500 plus minus 750 ohm for silver color, for silver color at the fourth band. Okay, then your B answer is going to be, means instead of gold I just change gold from silver, so the option is going to be changed. Clear everyone? Then your B answer is going to be correct. So how you can find the last one in this way? Everyone clear? Hari Mahesh, Shrutika, Kritika, Yajira, Muttu Kumran, Surushita, Kaila, Trivikram. Everyone means everyone. Okay, good. Focus on the next one. Now you tell me this. This is something good. The resistivity of a material of a conductor having uniform area of cross section and length according to the relationship this P equals to rho naught A plus dx. If L is the length of a conductor and B the B. Okay, this B is going to be area of cross section, then the resistivity of the conductor given by any relation. One thing, okay, try to solve it out because I give you the relation of non-uniform length also in the first class, if I'm not wrong, right? You remember in the Ohm's law class, V equals to IR. I deliberately I know this thing, that type of question you're going to face, so I teach you how to find the resistance of non-linear resistance. Means the length is going to be initially less. Okay, something look like this and this and this and that. Sorry, in this way. Remember, we have a, I mean, I give you one relation, something look like this. If you not, so obviously you need to focus there also. Okay, so try yourself first, and then obviously I'm going to help you out. And try within next 3 minutes. Next 3 minutes, I'll give you 3 minutes only, because 3 minutes is the maximum time I provide you. And then after 3 minutes, I'll help you out. Okay, go ahead. Because after then there is a one important question also, and that is very easy, because this resistivity is directly proportional to okay, we have I give you this relation, so I'm not going to tell you first. Area is A, you need to take, and the length is vary. So the length is vary, so the resistivity is vary in this way. So simply that is very easy. And which particular answer is this? Just let me know. And then we have one another good question. Okay. Sorry. Tell me which is A, B, C, D. Okay. I give you one hint. I don't want to, but let's for you guys. Sorry. I do this third time or maybe or second time on the camera. The resistance R equals to rho L by A, right? So instead of rho, simply we have A plus X. Sorry. Oh, what happened? Okay, give me a minute. Let me breathe once. So this is the relation. I mean, that is what relation we have. So instead of rho directly, which is uniformly, we have this. O naught A plus Bx. So beta, instead of L, you need to put Dx. And instead of R, you need to put Dr. Everything going to remain same, and you need to integrate in between 0 to L. Simple. Now I'm not going to tell you anything else. Neither I'm going to write. If you understand whatever I'm saying, you tell me the answer within next a minute or two. Instead of R, write dr. Instead of rho, write this relation rho naught A plus Bx instead of L, because it is going to linearly change dx, and then integrate from 0 to L. And that is very easy. Tell me which what is the correct answer then. And tell me a little bit quick, because we need to solve this CA also, class assessment. A. Yachida, how A beta? Where is alpha or beta? I mean A or B, where it is? Did you find A in A? Okay, because you guys take time. Sir, I think better don't think. You think so much. Don't think. Okay, so this is the hint. B. Don't question mark. The correct, what if you know the correct answer, then you tell me. See, Yajina tell me A, Harima is D, and then Dharmeshwar C, and then Sudarshan B. So now everything. So let's see what it was. What the correct one is. The correct one is B. Don't guess it out. How you need to solve C. Consider an infinitesimally small length of element dx. See, I give you this hint. So as we know, R is rho L by A. Okay. So instead of rho, we have what? Rho naught A plus bx. And I tell you, in that particular relation, I'm not going to draw. Okay, just for a while. This one, this one, this one, and this one. So what we're going to do in this scenario, in these kind of scenario, we take this kind of length element. This is your dx. We have this relation. So then instead of r directly, what we have? dr instead of rho naught a plus bx, and this is dx, and then this is a. Simple. Integrate, this is written over here. Integrate in between 0 to L. Why so? Because the length is obviously in between 0 to L only. And integration is very easy. So rho naught by A, because here we don't have any x, so dx become x, 0 to L, L, and then bx gives you bx square by 2, from 0 to L, bl square by 2. Simple. And this is just max 40 minutes. That's 40 minutes, 40 seconds numerical. Max. The moment you understand in this way, after that is 40 seconds. Clear, everyone? And see how much time you take. More than 6 minutes. It's okay in starting, but you need to do a practice keeping in mind like this. What I'm saying. Believe me in this. If you are preparing in this way, then you're going to get the good rank. Okay. First thing is understanding the question after reading twice maybe, and correlating whatever we have, whatever the relation you understand, whatever the concept you read out, you learn out, you understand, and then just mathematics, nothing more than that. Okay. In the same way, tell me the answer of this. What this particular question states that a material B has twice specific resistance of material A. Okay, we have two materials, a material B or a material A. So the specific resistance, what is the specific resistance? Resistivity is twice of A. If I'm reading correct, a material B has a twice specific resistance of material A. Correct. A circular wire made of B has twice the diameter of wire made of A. Now what it is? Suppose this is your wire, a circular wire made of B, yeah, and then this is your wire A. So if you're going to make a circle from this B, okay, this is your B circle, this is your A circle. Now it is correct. So a circular wire made of B has the diameter of the wire made of A, okay, twice the diameter. Again, so the diameter of this B, are you going to write R of B? Okay, diameter of B, and that is what, beta? Diameter of A. So diameter of B is again twice of diameter of A. What is meaning of this? Radius of B is twice of radius of A. Radius. Why radius is required? To find the area. Then LA by LB. Simple. Obviously they have, okay. Then for the two wires have same resistance. So that is they not. Okay. Now we know. Use this relation and tell me the LA by L. Simple. Clear? Whenever you read question, mark it out, whatever given. Try to picturize the thing and tell me the answer there. Rho A equals to rho, or rho B equals to 2 rho, D equals to D, dB equals to 2D. Then using the relation, find the resistance of a material of A. Then in a similar case, B, R equals to RB. So from there you can find the LA by LB, as simple as. Okay, and that is very easy. You have another 2 minutes. That's it. Tell me what is the correct answer, and in another 2 minutes, I'll let you know that. Okay, I write it down here as well. Resistivity of B equals to twice of resistivity of A. Better don't guess it out. If you calculate it, just be confident. Sudarshan. See, Sudarshan, I suggest you one thing. Solve it out. Look at it once. No calculated, sir. No calculate, sir. I did. What is the meaning of this? You calculate na properly. Then why you write guess? Either say A or either say another value. That's why I'm saying don't guess it out, because you write it down na A guess. So how can I say? Don't start guessing initially. Yeah, like Kritika, you need to give me the answer. Either A, B, C, D. That's it. Nothing guess it out. And don't put question mark after writing this. Obviously, I need to tell you guys. Where is 2x for 2b and A is x? Oh. So LA by LB you need to tell me. So if it is, you need LA by LB. Ratio, beta, ratio. Focus here also. Okay, the correct answer is A. Yeah. Okay, how we can find it? See, let LA and LB be the length, and it is given also. So given that rho A equals to rho, you can imagine, or you directly write it down. Rho B equals to 2 rho. Also, the diameter of A is dA, which is D, and then B for D. So resistance of RA, 4 into rho LA upon pi D square. Why pi D square? Pi RA square in general, where RA is dA upon 2. Okay, this is your area. So if you put that, you get this equation number 1. In a similar sense, you get this equation number 2. As we know from equation 1 and 2, RA and RB is given. This is given. So making equal LA by LB. That is how you need to do. Sudarshan, I find one thing good in you and one bad thing. I'll tell you both. You understand the thing quickly and solve the things quickly also. But at the end you guess it out. So don't do this. Okay. I mean, be confident on your calculation. If you are wrong, so it's learn from this particular mistake, like where I can do the mistake and how can I solve this in more quickly. Okay, everyone to each particular student I'm telling this. In this way, you need to approach the question, or because calculations and numeric value is going to be the more in general. So at the end of the particular thing, you need to put it down the numeric value or numbers. Okay. So this is the summary of class. In this particular class, what we clear it out: electrical conductivity, resistivity, limitations, resistance of some material, resistivity of some material, and temperature dependence. Each particular thing is important for board as well as or for your JE classes or courses as well.